Let's now discuss nomenclature and reactions of carboxylic acids and esters. So when we name a carboxylic acid, the suffix becomes oic acid. And just like when we named aldehydes, when we name carboxylic acids, the carboxyl carbon is automatically number 1, right? Because that's where the functional group is located. So you don't need to designate with a number where the carboxylic acid is located because we're assuming that that's carbon number 1. But you would need to note where the other substituents are if there are any substituents. So here's an example. We're going to begin numbering from the left. This is carbon number 1, 2, 3, 4. And we have a bromo as our substituent. So this is 3-bromo-butanoic acid. You don't need to write 3-bromo-1-butanoic acid. The 1 is not necessary because it's assumed that the carboxyl group is on carbon number 1. Here's another example, again involving bromines, and we've also got an ethyl group this time. We, by default, begin numbering from the carboxyl group. So 1, 2, 3, 4, 5, 6, 7, 8. So this is 4,7-dibromo, 5-ethyl octanoic acid. If you have 2 carboxyl groups, it's called a dioic acid. So for instance, this is a 4-carbon chain, so we call this butane dioic acid. And alcohols can react with carboxylic acids to form esters. Acid is the catalyst, and our other product is water, and this reaction is esterification. So here's an example. We've got a 2-carbon chain here and a 2-carbon chain here. Acids are catalyst. Okay, so here's where our water's coming from. Bloop. And then this part is going to become attached to this carbon. So we've got from here and then from here. We'll talk about how to name esters in just a second. But I want you to understand first the esterification reaction. Oops. All right, so if I gave you these reactants and said, okay, what are the products? Well, we're going to form water as our product. Yes. And then we're going to have a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 carbon chain attached to the carbonyl, and then we're going to have a 1, 2, 3, 4 carbon chain attached to the O. 1, 2, 3, 4. And then our other product would be water. So one piece of the molecule, this part that's attached to the carbonyl, came from the carboxylic acid, and this part of the molecule that's attached to the O came from the alcohol. That's important to note because that's how we're going to name esters. So when we name esters, we're going to name the part that came from the alcohol first. And then we're going to name the part that came from the carboxylic acid second. And our suffix is OATE. So for instance, if we're looking at this molecule, what's attached to the carbonyl? Well, the carbonyl counts as part of that chain. So this is a 1,2 chain, so we're calling that ethyl. And this is a 1-carbon chain, so that's a methyl. So we name the part that came from the alcohol first. So methyl ethanoate is the IUPAC name of this molecule. Here's another example. We're going to break it down. The part that includes the carbonyl, this piece came from the carboxylic acid. That's a 2-carbon chain. Don't forget to count this carbon as part of that. Okay, so that's ethyl. And then 1, 2, 3, this came from the alcohol. All right, so 1, 2, 3, so that's propyl. So the part that comes from the alcohol goes first. And the part that came from the carboxylic acid is second. So propyl ethanoate. All right, esters can undergo a reaction with strong bases called saponification. This is how we make soaps. So you're going to get your carboxylic acid back in a salt form, and then you're also going to get the alcohol back. So, for instance, if we're using ethyl ethanoate, there's the carboxyl part, there's the alcohol part. You're just going to undo the esterification. And it's going to be in the salt form. So sodium ethanoate and then ethanol. Instead of there being an H right here, you're going to have an Na+. So basically you're just undoing the esterification reaction. And that's an overview of nomenclature and reactions of carboxylic acids and esters.